Are we alone in the universe, or is intelligent life quietly watching us from afar? Could advanced civilizations be hiding or preparing to make contact? What if the cosmos is alive with voices we simply cannot hear? Today we journey deep into this enigma, the mystery of unseen alien life. For decades, scientists, thinkers, and dreamers have gazed into the night sky wondering, where is everybody? The universe is vast beyond comprehension, home to billions of galaxies, each containing billions of stars. It seems statistically impossible that we are the only intelligent beings, and yet, despite our powerful telescopes, deep space missions, and endless curiosity, we have found no clear evidence of alien life. Why? In today's episode of The Vast Unknown, we dive into this mystery from every angle: science, philosophy, technology, and even fear. We'll explore the barriers of interstellar travel, dive into chilling theories like the dark forest hypothesis, and consider strange possibilities like silicon-based life. Along the way, we'll visit the paradoxes that challenge our logic and keep scientists up at night. It's a journey that might change the way you see your place in the cosmos, forever. Our nearest neighboring star, Proxima Centauri, is more than 4.2 light-years away. In human terms, that's nearly 25 trillion miles. Even if we could travel at light speed, something no human craft has ever come close to, it would still take more than 4 years to get there. Right now, the fastest spacecraft we've ever built, the Parker Solar Probe, travels at 430,000 miles per hour. Impressive? Absolutely. But even at that speed, it would take thousands of years to reach Proxima Centauri. The challenge of interstellar travel is not just distance, it's energy, time, and survival. Future technologies like antimatter propulsion, fusion engines, and solar sails may one day get us there faster. But for now, the universe is just too big, and we're too slow. And if it's that hard for us, it might be just as hard for anyone else to get to us. Maybe aliens don't need to travel. They could just communicate. But again, distance is the enemy. Radio signals degrade as they travel. A message sent from a planet 100 light-years away could be so weak when it reaches us, it's indistinguishable from background noise. If a civilization is using different communication technologies, we might not even recognize their signal at all. It's like trying to tune into a radio station without knowing the frequency, or even if it uses radio waves at all. And there's one more problem: time. Civilizations may only be detectable for a short window. If an alien society had its technological peak 10,000 years ago and faded out, we might never know they existed. In cosmic terms, a few thousand years is just a blink. In 1950, physicist Enrico Fermi asked a simple, devastating question. If the universe should be full of life, where is everyone? This contradiction is known as the Fermi paradox. It's the tension between high probability and zero evidence. If there are billions of potentially habitable planets, and if intelligent life is even rarely the result of evolution, then there should be hundreds, thousands, or even millions of civilizations out there. So why have we never heard from any of them? This paradox has led to dozens of theories. One of the most unsettling is the one we're going to explore next: the dark forest hypothesis. Picture the universe as a vast, endless forest blanketed in darkness. You're not alone, but you can't see anyone else. Every tree may be hiding a watcher, a wanderer, or a predator. And in this forest, every intelligent civilization is like a silent hunter, creeping slowly, alert to every sound. Because in a place where you don't know who is out there, the greatest risk is being seen first. This is the essence of the dark forest hypothesis, a theory introduced by Chinese author Liu Cixin in his groundbreaking science fiction novel, The Dark Forest. It offers a chilling explanation for why the universe appears so quiet. Not because there's no one else out there, but because everyone is deliberately staying silent. In this view, civilizations don't announce themselves because they can't be sure whether others are friendly or hostile. There's no galactic trust, no interstellar diplomacy, just endless uncertainty. And in that uncertainty, survival instincts take over. It may be safer to destroy than to risk being destroyed. To speak is to reveal your location, and to reveal your location is to gamble with your existence. So perhaps there are countless civilizations out there, watching, waiting, listening, but none willing to speak first. They know what's at stake. Meanwhile, we've been broadcasting radio waves into space for over a century. Maybe, just maybe, we're the only ones making noise in a forest that has learned to fear the sound of a voice. We've already sent signals into space, TV broadcasts, radar sweeps, and deliberate messages like the Arecibo message in 1974. But should we keep doing it? Stephen Hawking warned against this, comparing it to the Native Americans encountering Columbus. His fear: a more advanced civilization may not see us as equals, but as resources. Others, like SETI researcher Douglas Vakoch, argue that it's too late. Our radio signals have already leaked out for over a century, and if aliens wanted to destroy us, they would have. This debate highlights our own duality, our hope for connection and our fear of it. When we search for alien life, we often look for a reflection of ourselves. Carbon-based organisms, breathing oxygen, relying on water, and living in temperate zones not too hot, not too cold. Our tools, telescopes, and experiments are tuned to detect signs of life as we know it. But what if alien life doesn't follow our blueprint? What if it is radically different, built on entirely unfamiliar chemistry? Many scientists believe it's possible that life elsewhere could be based on silicon, not carbon. Chemically, silicon sits just below carbon on the periodic table and shares some of its bonding capabilities. It can form long molecular chains and complex structures, but unlike carbon, silicon reacts poorly with water and forms rigid, rock-like compounds like silicon dioxide, essentially sand. Because of this, some researchers propose that silicon-based life would not evolve in Earth-like environments, but in extreme conditions, perhaps in the dense, acidic clouds of Venus, the frigid methane lakes of Titan, or in places with high pressure and low temperatures where unusual chemical reactions could thrive. In these alien worlds, what we consider toxic or barren could actually be nurturing to an entirely different form of biology. And here's the most intriguing idea. We may have already encountered such life, or overlooked it completely, because we weren't searching through the right lens. We might be blind to unfamiliar forms of biology simply because they don't emit the same metabolic signatures, don't move like we expect, or don't need what we require. In our quest to find life among the stars, we may need to broaden our definition of what life truly is, because the truth is, it might not look anything like us. Among the many theories seeking to explain the eerie silence of the cosmos, the Great Filter is perhaps the most sobering. It suggests that somewhere along the timeline from primitive molecules to advanced spacefaring civilizations, there exists a nearly insurmountable barrier, a filter so difficult to pass that almost no species ever makes it through. This filter could be behind us. Maybe the emergence of complex multicellular life is far rarer than we realize. Or the leap from basic intelligence to technological civilization might require a perfect storm of conditions we've been lucky to experience. But the more unsettling idea is that the Great Filter still lies ahead of us. If that's the case, then every advanced civilization may inevitably reach a point where it creates the means of its own destruction, whether through nuclear war, artificial intelligence, environmental collapse, or something even more unimaginable. If true, that would mean intelligent life is common, but self-preserving life is not. The Great Filter forces us to reflect deeply, not just on the universe, but on ourselves. Are we the lucky few who've passed the test, or the naive species charging toward it? In the silence between the stars, the answer may already be written. The silence of the cosmos may feel lonely, but it isn't meaningless. Maybe it's protection, maybe it's distance, maybe it's fear, or maybe it's something we haven't yet begun to understand. But silence does not equal absence. It might be the pause before a response, and one day, perhaps when we least expect it, the universe may answer back. Before you go, consider this. If an alien civilization tuned into Earth today, what would they think of us? Would they see potential or peril, curiosity or chaos? Would they reach out or quietly move on, ready to keep exploring the cosmos with us? Watch our next video and continue your journey into the vast unknown.